Now we have a good understanding of what vectors are, we can begin using them in operations. So let's start with addition. Here are two vectors, A and B, and we're going to add them. It's pretty obvious that the answer must also be a vector, and the answer vector is called the resultant vector. Now we're going to use a method that I call the Lock-Lomond method. This is probably the same method you use at school, but I bet your teacher doesn't have such a fancy name for it. The method is named after the famous Scottish song called Loch-Lomond, and I would sing it to you, but if I did, your eardrums would immediately explode, so I'll have to confine myself to the written word. And by the way, here's a wonderful picture of Loch-Lomond. Sorry, I digress. Now, the song contains the following lines. Oh, ye take the high road, and I'll take the low road, and I'll be in Scotland afore ye. Which, translated into English for all you non-Scots, is, oh, you'll take the high road, and I'll take the low road, and I'll be in Scotland before you. Now, when we add vectors, we have a high road. That is, the vectors we are adding together. And we have the low road, which is the resultant vector, the answer. The point of the song is that the low road is shorter than the high road, which is why it gets you to Scotland first. So let's see how this works in practice. Back to the two vectors that we're going to add, vector A and vector B. And as you're writing on paper, you'll put a squiggle under your vector names, don't forget. Now you'll remember that we can draw vectors anywhere on the page, so I'm going to keep the vector A where it is, and I'm going to move vector B so that the beginning of B is dropped onto the end of vector A. The resultant vector, the answer, is the vector that starts at the beginning of vector A and ends at the end of vector B. Now, I think you'll see why I call this the Lock-Lomond method. The long way round, i.e. along vector A and then along vector B, is the high road, while the direct distance from the beginning of vector A to the end of vector B is the low road, or the shortcut, you might say. The resultant vector is written as vector A plus B. If we wanted, we could call the resultant vector C, and then we would have the relationship C equals A plus B, all vectors of course. Now, doesn't this look very much like normal algebra? Well, that's another great thing about vectors. A lot of the methods that you use with algebra can also be used in vector work. In fact, this branch of mathematics is actually called vector algebra, just to make you feel at home. And we can also use this idea with vectors named after the points on a diagram. Take this simple triangle, for instance, labelled A, B, C. There's nothing special about it, just any old triangle. Let's say I start at point B and want to go to point C. Of course, I have two choices. I can go directly there, or I can go from point B to point A and then on to point C. So the long route via point A is the high road, the long way round, while the direct route is the low road, the shortcut. The low road is simply the vector BC, and the high road is vector BA plus vector AC. So now we can write the relationship between them. We say BC equals BA plus AC. The most important point to remember is that we are talking here about vectors, not actual distances as measured with a ruler. Obviously, the distance directly from B to C is not the same as the distances BA and AC added together. But we're not talking about distances, it's vectors we're interested in. And that's where the high road, low road concept is so powerful. The low road, vector BC, is the shortcut for the journey consisting of vector BA plus vector AC. So let's apply this idea to a more complicated diagram, and we can immediately turn to our regular hexagon again. Suppose I label the vectors FA, AB and BC as small a, b and c respectively. Notice the arrows showing the vector directions. I can now ask questions such as, what is the vector FB? Well, the low road is vector FB of course, but what's the high road, the long way round? That must be vector FA plus vector AB. So we can write vector FB equals FA plus AB. Now that's okay as far as it goes, but suppose the question is slightly different. Suppose the question is, what is the vector FB in terms of vectors A and B, using the lowercase notation? Well, that's easy, isn't it? It's obviously A plus B. So now we can write vector FB equals vector A plus vector B. And here we are quite happily mixing the capital letter notation with the lowercase notation, and not a headache in sight. Now you may have spotted that there's another way of getting from F to B, and that is via the points E, D and C. And I'll be getting back to that in the next video, because there's one other point we need to cover before we can tackle that. Just before we leave this diagram, can you see how to express the vector FC in terms of vectors A, B and C? The answer, of course, is that FC equals A plus B plus C. The vector FC, the shortcut is the low road, and the vectors A, B and C are the high road, the long way round. Just one quick point here, please make sure that when performing addition of vectors you understand that the high road and the low road both start in the same place and both finish in the same place. Always.